Hello there, welcome to another example video. In this example video, we are going to first distinguish the image of X-ray and CT scan. Okay, and then after that, we will do some calculation involving the linear absorption coefficient mu using a copper filter. So let's go. All right, distinguish between X-ray and body structure. You see, this one is 5 marks. Sorry, my head is blocking you. This is 5 marks, so you need to make sure you write at least 5 points. Not 5 points each, but at least in total, you should write 5 points lah. Okay, so the most straightforward one about X-ray image is that this is a 2D image. 2-dimensional image. Okay, whereas for CT, this is a 3D image. And not only a 3D image, number one. Number two, it can be rotated. So the image is a 3D image that can be rotated and viewed at different angles. Very nice. But what about the X-ray? 2D image can rotate, not really lah, okay? And in fact, you don't know the depth, okay? So you could say that the depth of the structure, the body structure, scan is unknown. So let's say you go and look at the X-ray scan, and then you see like a white, okay, you look at X-ray scan of someone, and you see a white color mass there, looks like a tumor. But how deep is the tumor? Is it halfway into the chest? Is it close to the front of the chest? Is it close to your back? Where is it? Unknown. Need to do a CT scan. Okay. Whereas for CT scan, we can rotate, we can look at it from different angles. We can tell exactly how deep inside the body the structure is. Okay. And I got 4 points here. I'm going to add a different point here. Number 3. We need to talk about the image. Okay. Please don't talk about the procedure. We're not talking about the procedure. We're talking about the image. Let me have here. Image. Do not discuss the procedure. You can, but you won't get marks lah. So what is another good thing about the CT scan? How do you get the CT scan image? This image is built, okay, from many X-ray images taken from different angle. Remember, we rotate and take a photo, rotate and take a photo. So taken from different angles and combine and process inside a computer. This is now just me flexing lah, okay? So the actual point that you need to write is image is built from many X-ray images taken from different angles. Okay? But since we're here, these images will be combined, processed inside a computer. So this is a slightly different question. Please make sure you answer the question and read properly, because in physics, right, we don't really emphasize on these skills because sometimes it's very straightforward what they want from you. But especially in this kind of application chapters, you have to see what they want. If it's distinguished between the properties or the harmful properties of X-ray image of body structure and CT scan, that will be a different past year question. X-ray is not as harmful as CT because X-ray only take one photo, whereas CT take many photo. Okay, so I guess if you want to, although this is not in the mark scheme, I will just complete it because I'm comparing them. Okay, so I will just say that a single image is taken. Okay, a single image is taken. All right, we're going to move on to part B now. And then here, you will see that there are two metals where the linear absorption coefficient mu is given. So your mu is in -1 and you have this number. And the X-ray radiation of energy 80 kilo eV. Not sure why we have this number. We keep it one side first. Maybe we will use it. Alright, so the X-ray beam parallel is incident on a copper filter. You want to use the X-ray attenuation equation. Your beams have to be parallel. Okay, so if you want to use this equation, I is equal to I naught E negative mu X This one is for parallel rays only. Parallel X-rays only. Alright. So the intensity of the incident beam is I naught. Then there's some of it that passes through. Some of it will be absorbed by the copper filter. Beautiful. Let's continue the question. Calculate the thickness of copper required to reduce the intensity of the emergent beam to 0.25 I naught. So what we have here just now was the copper filter, and then we have the incident B I naught, and then the emergent beam, I just want 0.25 I naught. Okay, maybe I don't need such an intense beam to protect my patient. Okay, so this is used as a filter. So I guess we could write the general equation first. I is equal to I naught E negative mu X. And right now, our I is 0.25 I naught. Okay, because this is I. Emerging from the filter. Okay, and this is I naught E negative. What is the linear absorption coefficient for copper? Let's go back and copy the copper mu. The copper's mu is 0.69. So 0.69. I'm just going to put this here. And we are looking for the thickness X. All right, 0.69 for copper, right, is already in -1. Okay, so we already have this here, -1. All right, so we're gonna now find find X. I naught and I naught will cancel out. Okay, so I will have 0.25 is equal to e to the negative 0.69 X. What do we do when we want to solve an exponent? We take ln at both sides. Okay, so we have ln 0.25, and this will be equal to ln bracket e negative 0.69 X. Again, doing this for the benefit of people who are not used to lns and exponents. If you are, you feel free to skip some steps. Okay, so right now we will have ln bracket 0.25, which I can press inside my calculator, and then this power here, negative 0.69x, can bring down. All right, so this will be negative 0.69x, and what is left inside the equation is ln e, which is 1. All right, so I think now I can press down. X will be equal to ln 0.25 divided by negative 0.69. So if we press calculator for this, ln 0.25 over negative 0.69, you will get 2.009 positive. So 2.009 or 2.01 mm. Okay, so this mm here, follows this -1. So that when you substitute inside the exponent, the units cancel out. All right, you cannot exponent something with a unit. All right, so this is X. So you can put 2.0 mm, you can put 2.01 mm, it's okay. All right, now we have an aluminium filter. New filter. Okay, sure. And our aluminium filter has a thickness of 2.4 mm. Now placed in the X-ray beam together with the aluminium filter in one. Okay, so basically what we're saying is we now combine two filters. We have the copper Cu filter, and then at the back we will have another aluminium filter, Al. Okay, and the thickness is different, huh? The thickness for copper is 2 mm, we calculate already. And this thing is 2.4 mm. They obviously have different linear absorption coefficient, mu. They have different. So right now, what they want you to find is the fraction of the incident intensity that emerges after passing through 2 filters. So you filter 2 times. So instead of putting them back to back like this, I think what I'll do is I'll put aluminium back a bit. And I'll start with I0. So we're going to incoming with I0. And after this, what will escape here is 0.25 of I0 with this 2 mm copper filter. Filter twice, ma. Nobody say the filter have to be touching also. Alright, so we're going to now have aluminium here. This aluminium is slightly thicker. 2.4 mm. Let's say the intensity that comes out from here after passing through the aluminium filter is I prime, I1, IX. You can call it whatever you want. Let's say I call this I prime. So they want the fraction of the incident intensity, meaning I want something that looks like 0.25 I0, or in terms of incident intensity I0. So I want to find I prime as something something I0. Like this is 0.25 I0, right? So I want to find this one as something something I0. So I guess the question now is we need to use the linear attenuation equation once again, but this is for the 2.4 mm. Okay, so I'll write the equation again because we're going to use it. I is equal to I0 E negative mu x. Okay, so once we have written the attenuation equation, we are now going to apply this specifically for the aluminium filter. Okay, or the aluminium filter. And if you want to use it for the aluminium filter, right now we have to understand from the perspective of the aluminium filter, this 0.25 I0 is the incident one. So when you use this equation, this I0 is the one that incident the aluminium filter, and this I is the one that passes the filter. Okay, so incident the aluminium filter would be 0.25 I0. Okay, this will be E negative. What is the linear absorption coefficient for aluminium? Let's go back to the table to look at it. Aluminium here will be 0.46 mm negative 1. So in case I need it again, I'll just write here. For Al, our mu is 0.46 mm negative 1. Okay, so this will be negative 0.46 times 2.4. And this is the amount that passes the filter. This will be our I0. Okay, so incident filter is this I0, passes through the filter. This one is your I. Okay, so basically what we're doing is we're taking this beam incident and the other side as passing through. Okay, we can now press calculator and we just want a fraction. So I think we got our answer already. So I will have I0 is equal to, I prime is equal to, I'm just going to press my calculator, press 0.25 times exponent E to the power of negative 0.46 multiplied by 2.4. And that will give me 0.08288. Wow, the inner Chinese in me likes this number. 0.829. Okay, so when writing to 3SF right? So now my I prime will be equal to 0.0829 I0. You can leave it as a fraction, which is I prime over I0 is 0.0829 or 0.0829. Okay, so this is one method lor. An alternative is to just think about the aluminium filter equation and straight away take the ratio of I over I0. This will be equal to E negative 0.46 times 2.4. Okay, so hence transmitted in aluminium, the ratio I over I naught is, you press this calculator, E negative 0.46 times 2.4, you will get 0.33. So if transmitted through aluminium is 0.33, but transmitted through copper is 0.25, so you can then say, hence, the total transmission or the resultant transmission, I guess, resultant transmission will be equal to 33% or 0.33 of 0.25, which is what you're multiplying here. What, see, 0.25, this whole thing here is 0.33. Okay, so right now, if you press your calculator, you will get, I mean, this one might not be exactly the same because it's rounded, but 0.825, so close enough lah. I guess you round this is 0.083. So the blue color method is okay. You just find the ratio for aluminium and you multiply by the ratio of copper. Because in copper, 25% pass through. In aluminium, 33% of the 25% pass through. So you incoming, you got 100%. Pass through copper, you got 0.25%. Pass through aluminium, you have 33% of the 0.25. 33% of the 0.25. So yeah, I can't change highlighter. So are you highlighting for me? Okay, 33% of the 0.25. All right, that's how you get 0.083, or rather just about 8.3% passes through. Okay, so that's done. Let's move on to the next part. Express your answer in gains in decibel. Ooh, okay. So decibel, if you remember gain last time when you learned op-amp is the ratio of V out to V in. So gain in decibel is decibel lah. LG, the ratio of I over I. So right now, what are you ratioing? You are ratioing I prime over I naught, which is what you have here, this fraction, 0.0825, or you could also use this. So by looking at this fraction, what I need to do is 10 log, I already found the fraction anyway, 29. Ooh, and I press my calculator, or 0.083, 10 log 0.083, that will give me negative 10.81 or negative 10.8 lah, to show that there's an attenuation or a decrease in intensity. So negative 10.8. Okay, so this negative shows us that the intensity decreases. Intensity drop after filter, which is the point, right? You want the filter to remove some of the intensity of the X-ray. And then you look at this one, I also don't know why this is 3 mark leh. Because 1 mark is writing the equation, 1 mark is the substitution, 1 mark is the final answer. Very nice. So don't ignore decibel. If it comes out, it's always a very sweet bonus. Whereas this one, so much, only 2 marks. 1 mark is for a suitable calculation. Either you arrive at 0.33 or you substitute and you substitute this one. Is your 1 mark. And then final answer is your 1 mark. Okay, so either you find the ratio of transmitted through aluminium, which is 0.33, that will get 1 mark, or you substitute correctly in this expression. This one, you want to find the thickness. Again, substitute correctly in the expression. Final answer is 1 mark. So I'm not sure why decibel so much mark, but why not? Okay, so that's it for this filter question. Remember that X-ray can pass us through certain intensity, and we stack the ratio because we filter 25% and then we filter 33% of the 25%. So we let 25% of the initial value pass through, and out of the 25%, we only let 33% pass through. Don't forget decibel is 10 log ratio of intensity. So just put this one inside because they already say your answer in 2 must per inside and can find out. All right, cool. So questions like this can be very easy as long as you have enough practice. So please go try more X-ray partial questions or CT scans, and I wish you all the best in your A2. Let's master A2 together by sharing this video with your friend and subscribing to the channel, and I will see you in class in the next one. Wherever I'll see you lah. Take care. Bye-bye.